further math there. And we're looking at proving. We are looking at proving. We are looking at proving. Want to prove. Proving. So, as I showed that cos theta plus sin theta over cos theta minus sin theta minus cos theta minus sin theta over cos theta plus sin theta equals to 2 tan 2 theta equals to 2 tan 2 theta. So, what do we do? The first thing, this, you want to prove that this left-hand side is equals to the right-hand side, or you prove that the right-hand side is equals to the left-hand side. But I'm going to start from the left-hand side. This is my left-hand side. I'm going to start from my left-hand side. So I'm going to prove that it's equals to 2 tan 2 theta. So what's the first thing? I'm going to find the LCM. We have cos theta minus sin theta. The LCM is this 2 is the LCM plus sin theta. Cos theta minus sin theta, here we have cos theta plus sin theta. So multiply by this. This is cos theta plus sin theta square minus here. This is out. So you have this times this. So we have cos theta minus sin theta square. So what's the next thing to do? We multiply it twice. We do what? We multiply it twice. We multiply it twice. Minus cos theta minus sin theta. Cos theta minus sin theta. Over this times this, we have cos square theta. This times this, that will give us plus cos theta sin theta. This times this minus sin theta cos theta. This times this minus sin square theta. So this 2 is out. So you multiply. This times this is going to be cos square theta. This times this will be plus cos theta sin theta plus cos theta sin theta. This times this plus sin square theta minus this times this, we have what? Cos square theta. This times this, we have what? Minus cos theta sin theta. This times this. This times this, we have this. This times this, we have this. This times this, we have this. So we have minus cos theta sin theta. This times this, we have plus sin square theta. Sin square theta. So, over cos square theta minus sin square theta. So the next thing we'll do is we have cos square theta plus 2 cos theta sin theta plus sin square theta minus cos square theta. This times this. Then this is minus minus. That becomes 2. So minus times minus become plus 2 cos theta sin theta. Then minus times plus, we have what? Minus sin square theta over cos square theta minus sin square theta. So the next thing to do is this cancel this, this cancel this. So we have 4 cos theta sin theta over cos square theta minus sin square theta. And this one, cos square theta minus sin square theta, is a log of cos 2 theta. Is a log. Is actually a log. So this one is 4. Remember, sin 2 theta is 2 cos theta sin theta. Then cos 2 theta is cos square theta minus sin square theta. So this equals to, this is 4, so it's going to give us 2 into bracket 2 cos theta sin theta over cos square theta minus sin square theta. So we have 2 sin 2 theta over cos 2 theta. So that gives us 2 tan 2 theta. That is our answer. That is our answer. We have 2 tan 2 theta. We also have another one. We also have another one to prove. So it has been proved. You can see that the right hand side is now equal to the left hand side. Is now equal. Now the next thing to do is to prove. Let's prove the second one. We have 1 minus sin theta over 1 plus sin theta. That's going to give us sec theta minus tan theta square. So what do we do here? We rationalize. The first thing to do is to rationalize. We rationalize. So the first thing to do is to rationalize. So we have 1 minus sin theta over 1 plus sin theta. So you rationalize. Whenever you want to rationalize, rationalize means you change the negative sign of the denominator. So we have 1 minus sin theta over 1 minus sin theta. So what do? We use this to multiply it. So we have 1 times 1, 1, minus 1 times this, we have sin theta. This times this, we have minus sin theta. Minus times minus, we have what? Plus sin squared theta. All over 1 times 1, we have what? 1. This times this, we have minus sin theta. This times this, we have what? Plus sin theta. This times this, we have what? Minus sin square theta. So what do we do next? We have 1 minus 2 sin theta plus sin square theta over, which has cancelled this. So we have 1 minus sin square theta. 1 minus sin square theta. Don't forget, this is what we want to prove. This is what we want to prove. So, what do? When you have something like this, we can rewrite it as sine squared theta minus 2 sine theta plus 1 over 1 minus sine squared theta. So when we have something like this, this is like a quadratic equation. The numerator is a quadratic equation. The numerator is a quadratic equation. So when you have something like that, we have sine square theta minus 2 sine theta plus 1. What do you do? What do you do? Very simple. You can tell them that let sine theta equals to y. So we have y squared minus 2y plus 1. So what do? You let them know this is a quadratic formula. And in quadratic formula, the power is y squared. Thank God, the coefficient for y squared is 1. So you use this to multiply this. We have 1 times 1, that is 1. We have 1. So you find two factors that when you multiply it, it's going to give us 1. Two factors that when you multiply it, it's going to give us 1. And when you add it up, it's going to give us minus 2. So if we are talking about factors of 1, factors of 1 is 1 and 1. 1 and 1. Another factor is when you start changing the sign. You can have minus 1 and minus 1. So when you multiply this, 1 times 1 is going to give us what? 1. When you add it up, 1 plus 1 is going to give us 2. The same thing here. When we do minus 1 times minus 1, we have what? 1. When we add it up, it's going to give us what? Minus 2. So when you have something like y squared minus 1y minus 1y plus 1. So you bracket, you bracket, you bracket. So what do you have? We have y into bracket y minus 1 minus 1 into bracket y minus 1. So we end up having y minus 1 square. We end up having y minus 1 square because it's as if you are repeating this, y minus 1. So that is y minus 1 square. So what's the next thing to do? The next thing to do is y minus 1. We have square. Remember our y is what? Our y is sine theta. So this is sine theta minus 1 square. Sine theta minus 1 square. And if you don't do it that way, you can decide to go back to this. So you write, when you go back to this, you write sine square theta minus 2 sine theta plus 1 over, this is 1 minus sine square theta. Remember that sine squared theta plus cos squared theta equals to 1. And when you have cos squared theta, it's going to give us 1 minus sine squared theta. 1 minus sine squared theta. So this is going to give us cos squared theta. So what do? You separate. We have sine squared theta over cos squared theta minus 2 sine theta over cos squared theta plus 1 over cos squared theta. So what do? This is going to give us tan squared theta. This is going to give us tan squared theta. Remember, sine over cos is what? Tan squared theta. Sine over cos is what? We have minus 2 sine remember, maybe I should break it down. Sine theta over cos theta times 1 over cos theta plus 1 over cos. 1 over cos is what? 1 over cos is sec. So this is sec squared theta. So this is tan squared theta minus sine over cos is what? Is tan. So we have 2 tan theta. 2 tan theta sec theta plus sec squared theta. Sec squared theta. So what do you do? What do? You can decide to rearrange. You can decide to rearrange. I can decide to bring my sec squared theta here. Minus 2 tan theta sec theta minus, plus tan 2 theta. So this is still forming a quadratic equation. I told you, this is still forming it. So I'm taking it in another way. So this is still forming a quadratic equation. So this is like sec squared theta minus tan theta sec theta minus tan theta sec theta plus tan 2 theta. So you do it in 2 ways. 2, 2, 2, 2, 2, 2. So sec theta into bracket. Sec is common. We have sec theta minus tan theta. Here 2 is common. What do you do? This is common. Tan. So we have tan theta into brackets what? So this is minus sec theta plus tan theta minus sec theta, or possibly I can decide to bring minus out. When I bring minus out, what happens to this? This becomes positive and this change to what? Negative. Do you understand? So from here we have sec theta minus tan theta, sec theta minus tan theta. So they are common. We end up having 3 squared. It has been what? Proved. So this is equals to this. So our right hand side is equals to left hand side. Has been proved. It has been proved. So I'm going to give you work to do. So you try this. So you try this. Let me try to find. Okay, we have sine exercises. We have sine 2a over 1 plus cos 2a. Sine 2a over 1 plus cos 2a. 1, then 2. We have cos 2a equals to 1 minus tan squared a over 1 plus tan squared a.